Hello and welcome to my YouTube channel. In this video, we have this exponential equation 4 to the power of x is equal to 20, and we are required to solve for x. To begin, I'll have to break down the right hand side, which is 20 to 4 times 5, which means I have 4 to the power of x is equal to 4 times 5. Then I'll need to divide through by 4 to get rid of this 4 on the right hand side. So I'm left with 4 raised to power x divided by 4 is equal to 5. Now, according to the law of indices, when you have the same base here, this 4 at the denominator can also be written as 4 raised to power 1. Of course, we see we have the same base, but we have different powers. The law of indices says if you have, for instance, a raised to power m divided by a raised to power n, this can be written as a raised to power m minus n. So applying this law of indices, I'm going to express this as 4 raised to power x minus 1. So that I now have 4 raised to power x minus 1 is equal to 5. Now it's easier to see where our unknown variable is and how to solve for it. What I'm going to do now is take the logarithm to base 10 of both sides. I now have log to base 10 of 4 raised to power x minus 1 is equal to 5, is equal to log 5. Both are in base 10, and there's a law of logarithm that says that if you have, for instance, the logarithm of a raised to power n, this can also be expressed as n log a, regardless of whatever the base is. In this case, we have base 10 on both sides, but this power, according to this law, can be transferred to the back. The power x minus 1 can be transferred to the back. We now have x minus 1, then log 4 is equal to log 5. And with this, I'm going to divide through by log 4, divide through by log 4, so that this gets rid of this, and I'm left with x minus 1 on the left hand side is equal to log 5 divided by log 4. There's another law of logarithm that says if you have, for instance, log x over log y, as long as both logarithms are in the same basis, you can consolidate them into one logarithm with the one at the numerator written as so, and the one at the denominator, which is y, becoming the base. So log x divided by log y becomes log x base y. So invariably, what we have here, log 5 divided by log 4, can also be expressed as log 5 base 4. So going back to our equation, it means we now have x minus 1 from here. X minus 1 is equal to log 5 base 4. So I have x minus 1 is equal to log 5 base 4. Then I can add 1 to both sides. I say plus 1 plus 1. So this cancels this, and then x is equal to log 5 base 4 plus 1. This will be our final answer. And now to confirm that log 5 base 4 plus 1 is a solution to 4 raised to power x equal 20. Let us put this value into this x and it must give us 20. So we check. This becomes 4 raised to power log 5 base 4 log 5 base 4 plus 1. This must give us 20. To break down this power, this 4 raised to power log 5 base 4, remember the law of logarithm that says that if you have x to power log, say y base x, as long as the base here are the same and there is no coefficient, there's no coefficient here, this is 1 log y base x. As long as the coefficient is 1, the result is always this y here. It's a known law in logarithm. This simply means that for this first part, log 4 raised to power log 5 base 4, the result will be 5. But because we have a plus 1, we need to first separate this power using the law of logarithm. Remember that if you have a raised to power m plus n, the law of logarithm allows us to separate this into a raised to power m times a raised to power n. So that is what we are going to do with this power here. So it simply becomes 4 raised to power log 5 base 4 then times 4 raised to power 1. Remember, this should give us 20. Now with what we solved earlier, the whole of this first part is simply 5 by this definition that we did here earlier. So we have 5 then times 4 raised to power 1 is simply 4, which is actually equals to 20. And because 20 is equals to 20, it means that our solution x is equal to log 5 base 4 is actually accepted. Thank you so much for watching. Hit that like button and subscribe to my channel if you are yet to do so, and I'll see you in my next video.